James Webb has just captured the birth of a gigantic star, and the discovery is drawing the attention of astronomers around the world. In a universe filled with billions of stars, witnessing one of them being born would already be extraordinary. But observing the birth of an extremely massive star, capable of exceeding dozens of times the Sun's mass, is a rare and valuable event for science. For decades, scientists have tried to understand exactly how these cosmic giants form. The problem is that a star is born inside dense clouds of gas and dust. Regions so dark that most telescopes simply can't see what's happening inside them. It was like trying to watch a flame appear in the middle of a sandstorm. The information was there, but it remained hidden. It was precisely in this setting that the James Webb Space Telescope went into action. Equipped with extremely advanced infrared instruments, the observatory was designed to pierce these cosmic dust barriers and reveal details invisible to earlier generations of telescopes. And when it pointed its instruments at one of these star-forming regions, the results exceeded expectations. What James Webb observed was a gigantic protostar still in its earliest stages of development. A protostar is the initial stage in a star's life. At this point, huge amounts of gas are being pulled by gravity into an increasingly dense and hot central region. The object has not yet reached its final form, but it is already gaining mass at an impressive rate. The images revealed complex structures of glowing gas, cosmic filaments, and huge cavities carved by the energy released by the forming star. These features act like fingerprints of the star birth process, providing valuable clues about phenomena scientists have been trying to understand for decades. What makes this observation so special is that giant stars usually form very quickly in astronomical terms. They gather matter at extreme speeds and begin emitting colossal amounts of radiation while they are still forming. This energy tends to push away the surrounding material, making the process highly turbulent and difficult to study. Because of that, capturing detailed images of this early stage is extremely rare. The data collected by James Webb made it possible to observe regions where matter continues flowing toward the protostar while energetic jets are launched into space. This combination provides direct evidence of fundamental mechanisms in the formation of massive stars. But it wasn't just the quality of the images that impressed researchers. The environment where everything happened also drew attention. The star is located inside a gigantic molecular cloud, a kind of cosmic nursery made of hydrogen gas, interstellar dust, and chemical elements produced by earlier generations of stars. These regions can contain enough material to form thousands of new stellar systems. Inside these clouds, temperatures can be extremely low, while the material density varies drastically from one region to another. Small gravitational instabilities cause certain areas to begin collapsing, starting the process that will eventually give rise to new stars. James Webb was able to observe this environment with an unprecedented level of detail. For the first time, it was possible to map delicate structures hidden beneath layers of dust that had previously blocked our view completely. The images reveal an impressive scene. Giant columns of matter stretch for light years. Streams of gas seem to converge toward the center of the region. Areas lit by radiation from the newly formed star contrast with dark zones still dominated by dense dust. It's like looking at a photograph of a process that normally remains invisible. And there's another factor that makes this star different from most. Most stars in the universe have relatively modest mass. Our Sun, for example, is considered an intermediate-sized star. Massive stars, on the other hand, make up only a small fraction of the total stellar population. Even so, they exert a gigantic influence on the cosmos. And they are the ones that end their lives in spectacular explosions known as supernovas. For many years, different theoretical models have tried to explain this process. And it was exactly at that moment that something unexpected happened. Enormous amounts of energy began escaping from the forming protostar. The energy storm that changed everything. As the protostar continued accumulating matter, something extraordinary began to happen. The object that had until then remained hidden within the molecular cloud began releasing gigantic amounts of energy into the space around it. It was the sign that stellar birth had entered a new phase. For a long time, scientists believed that matter simply fell toward the star until it reached its final form. But the most recent observations reveal a more dynamic and violent reality. While enormous quantities of gas continue to be pulled in by gravity, part of this material is violently expelled into space. The James Webb instruments recorded clear evidence of this phenomenon. Colossal jets of matter were being launched outward from the central region at astonishing speeds. These streams of superheated gas crossed the nebula like true cosmic projectiles, carving paths through the material surrounding the forming star. These jets are not simple leaks. They play a fundamental role in the star's growth. As matter rotates around the forming core, extremely intense magnetic fields help channel part of the material toward the poles of the system. The result is energetic currents that can extend across distances equivalent to several light years. James Webb was able to observe details of these structures with unprecedented precision. The images show bright regions where the jets collide with the surrounding material, producing zones of intense heating and creating complex patterns within the nebula. But the jets were only part of the story. At the same time, the protostar began emitting increasingly higher levels of radiation. As more matter accumulated in its core, the temperature increased dramatically. The energy produced began escaping in all directions, gradually illuminating the surrounding environment. This radiation was so powerful that it began completely altering the structure of the molecular cloud. Areas that were once cold and dark began to glow. Dense regions started to disperse. The balance of the environment was changing before the researchers' eyes. And then the shock waves emerged. When the jets and radiation interact with the surrounding gas, they create impact fronts capable of traveling great distances within the nebula. Imagine a stone thrown into a lake. The waves spread in all directions from the point of impact. Now imagine this same phenomenon happening on cosmic scales. Observations indicate that these waves were compressing certain regions of the cloud while dispersing others. In some cases, this can even trigger the formation of new stars nearby. In other words, the birth of a single massive star can directly influence the emergence of many others. This is one of the reasons why giant stars play such an important role in the evolution of galaxies. They do not simply emerge within the cosmic environment. They transform that environment. But none of this would be visible without James Webb's unique ability to see through interstellar dust. Before its arrival, much of these events remained hidden. Visible light simply cannot penetrate the dense curtains of dust present in these regions. Previous telescopes observed only fragments of the story. Webb completely changed this picture. Its infrared sensors can detect wavelengths capable of passing through these barriers, revealing structures that remained invisible for decades. Thanks to this technology, scientists were able to identify specific signatures that confirmed that the process of stellar formation was occurring at that exact moment. Active flows of matter were detected, regions heated by the protostar's radiation, and energetic patterns compatible with the most advanced models of stellar formation. For the first time, researchers were not only inferring what was happening, they were directly observing the signals of the ongoing process. Each piece of data collected helped reconstruct an extremely complex sequence of events, a sequence that shows how a simple concentration of gas can evolve into one of the most powerful objects in the universe. However, the star itself was not the only discovery. The surrounding environment hid clues that could reveal how some of the universe's biggest stars truly form. To understand what James Webb really found, we need to look beyond the forming star and explore the place where it all began. Because no star is born alone. Before a star exists, there is a vast cosmic nursery capable of providing all the raw material needed for its creation. These nurseries are known as giant molecular clouds. At first glance, they may look like nothing more than huge dark patches scattered through space. But in reality, they are among the most important structures in the universe. They are vast regions made mainly of molecular hydrogen, mixed with cosmic dust and small amounts of other chemical elements. Some of these clouds span hundreds of light years and contain enough mass to produce thousands of stars over millions of years. This is where the story begins. For long periods, these clouds can remain relatively stable, but the balance is never perfect. Small disturbances arise constantly. A nearby supernova explosion, shock waves crossing the galaxy, or even collisions between clouds can trigger major changes. When that happens, certain regions become slightly denser than the rest of the cloud. It may seem like a tiny difference, but in the universe, gravity amplifies any initial advantage. As a region gathers more matter, its gravitational pull increases. This draws even more gas to the same place. The process feeds on itself, growing stronger and stronger. That is when gravitational collapse begins. Billions of tons of gas and dust begin a slow fall toward the center of the densest region. As the material builds up, pressure rises. Particles collide with one another at increasing speeds. The temperature begins to rise. What was once just a slightly denser area of the cloud turns into something completely different. A stellar seed is emerging. Data from James Webb made it possible to observe details of this process with striking clarity. Giant filamentary structures were identified, channeling matter directly into star-forming regions. These filaments act like true cosmic highways. Along them, huge amounts of gas flow slowly toward the centers of gravitational collapse. This continuous supply of matter is one of the factors that allows some stars to reach extraordinary masses. But forming a giant star is not simple. In fact, it is one of nature's greatest challenges. While an ordinary star may grow relatively steadily, a massive star faces an unexpected problem. As it gathers matter, it begins producing ever greater amounts of energy. That energy creates intense outward pressure. At a certain point, that pressure should be strong enough to stop the infalling material from continuing to arrive. In theory, the star itself should prevent its own growth. For decades, this question puzzled astronomers. How can stars dozens of times more massive than the Sun keep growing even while releasing enough energy to blow away the surrounding material? James Webb's observations are providing important clues to answer that question. The images show that matter does not reach the star uniformly. Instead, it is funneled through specific structures, allowing huge amounts of gas to keep feeding the forming object. This discovery helps explain how some stars can surpass limits that once seemed impossible. At the center of this process, the stellar core is born.